Hey there. In this quick start guide, we'll walk you through setting up Interaction Master and building your first Interactable, with full multiplayer support. Let's take a quick look at what you'll have by the end of this tutorial. A complete, replicated Interactable ready for your gameplay, fully compatible with both keyboard and mouse and gamepad. Let's get started. First, create or open your project. Once the editor is open, we'll enable the required plugins. Go to Edit Plugins. Search for Enhanced Input and make sure it's enabled. Then search for Common UI and enable it as well. Then restart the editor to apply the changes. Once the editor has restarted, go to Edit Project Settings. Search for Enhanced Input, and make sure the Enable Enhanced Input Support option is checked. Next, search for Game Viewport, and set the Game Viewport Client class to Common Game Viewport Client. Then go to Edit Plugins, search for Interaction Master, and enable it. Finally, restart the editor one more time to apply all changes. Once the editor has restarted again, make sure that Show Engine Content and Show Plugin Content are enabled. Go to Edit Project Settings again. Search for controller data and add the appropriate controller data for your platform. If you already have your own controller data set up, you can keep it. Next, let's add the input binding to handle interaction. Open your input mapping context and add a new entry for I_interact. You can assign any input key you like. Just make sure the corresponding controller data is correctly set in your controller data asset. Now we'll set up the player controller. If your project doesn't already have a custom player controller class, create one. Then open your game mode class and assign your custom player controller as the default. If you already have one, simply open it. We'll modify it next. Go back to your custom player controller class and add an interactor component to it. Next, we'll create the UI that will display the interaction prompt. Right-click in the content drawer and select User Interface Widget Blueprint. Choose Common User Widget as the base class. Open the widget, add a canvas panel, then search for Interaction Widget and add it to the canvas. Position it correctly within the UI layout. Once that's done, save everything and go back to your custom player controller class. We'll now create the UI widget and add it to the viewport. If you're setting this up for a multiplayer project, make sure to check that his local player controller is true before adding the widget. Next, we'll implement the input handling for the interact key by calling the appropriate function on the interactor component. Connect started event to start interaction and completed event to stop interaction. Now we're going to configure collision settings so that NPCs can be detected by the visibility trace channel. By default, the interactor component uses the visibility channel to detect interactables, but you can assign a dedicated trace channel if you prefer. If you choose to use a custom channel, don't forget to update the trace channel property on the interactor component accordingly. Now let's make sure everything is working correctly. I'm going to add a lockable door and an unlock button to the level. These examples are included with Interaction Master and can be found in the Plugins Content folder. Now I'm going to test in multiplayer with 2 clients. To do this, set net mode to play as client and number of players to 2. If everything is working correctly, you'll see that the door appears as locked. After pressing the unlock button, the door becomes usable. You'll also notice that when one player interacts with the door, the other can't interact at the same time. This behavior is controlled by a setting and can be enabled or disabled depending on your needs. Now let's see how to create an interactable. We'll go step by step through how the door example was made. First, create a new blueprint and choose Actor as the base class. Add 2 static meshes, one for the door frame and one for the door itself. Position the door mesh properly so it fits into the frame. In the class defaults, enable replication so the actor is network ready. Next, add an interactable component to the actor. This component gives interaction functionality and exposes events. The one you'll use most often is onInteracted. Click it to add the event to your event graph. Now, let's create a Boolean variable called open to represent the door's state. Make sure it's replicated using rep notify. This way, when the state changes on the server, the clients are notified and we can animate the door accordingly. In the onInteracted event, flip the value of the open variable on the server. Since it's replicated, it will automatically update on the clients. Now create a custom event called updateDoorState. This event will handle the animation of the door depending on whether it's open or closed. To animate the rotation, we'll use a timeline. Add a float track with 2 keys, and apply a smooth curve for a more natural animation. When opening the door, play the timeline. When closing it, reverse the timeline. During the timeline update, set the relative rotation of the door mesh on the z-axis. Now implement the rep notify. Each time the open variable changes, call updateDoorState to animate the door. Place an instance of the door in your level and test it. The door should work, but the interaction text may still show default values. To fix this, go back to the blueprint and select the interactable component. Update the properties: interactable name, action name, and interaction required time. You can also adjust the max interaction distance. Try again. Now the correct text is displayed, and you need to hold the interact key for the configured time to trigger it. You'll also notice that only one player can interact with the door at a time. That's because network locking is enabled. Now let's disable network locking and see what happens. Both players can now interact with the door at the same time. Great, now let's add a lock system to the door. To do that, we'll create a custom interactable component. Create a new blueprint and choose interactable component as the base class. In this component, override the function canInteractWith. Add a replicated locked variable to control whether the door is locked or not. Inside canInteractWith, add logic to block interaction when locked is true. Once that's ready, return to the door blueprint. Remove the existing interactable component and replace it with your new interactable_door_with_lock component. Update the event graph to bind onInteracted to the new component. Set the locked variable to true for testing. Try it out, the door should now be locked. Again, don't forget to update the interactable properties so the correct text is shown. Now let's create a button that unlocks the door. Create a new blueprint based on actor and enable replication. Add a cube as a visual for the button. Add an interactable component, configure its properties, and implement onInteracted. Add a variable to reference the door, and in the event, set the door's locked variable to false. Since it's replicated, clients will see the update too. Place the button in the level, set the door to unlock reference. Test it, everything should now work as expected. There's still one small issue. The action text always says open, even if the door is already open. To fix this, go back to the door blueprint. In the update door state event, call set action name on the interactable component and update the text based on the open state. Test again. Now everything works exactly as intended. Let's go one step further and add another prerequisite. This time the player will need to find a key to open the door. If they don't have it in their inventory, they won't be able to interact with the door, even if it's unlocked. Interaction Master includes a very simple replicated inventory component, which is perfect for testing this out. Let's start by creating a pickable item blueprint. Create a new blueprint based on actor, add an interactable component, and place a cone mesh to represent the item visually. Select the interactable component and click on Interacted to generate the event in the event graph. We'll need the inventory system for this to work, so let's open the custom player controller class and add the BPC_per inventory component. Now go back to the pickable item blueprint and implement the onInteracted event like this. It will add the key to the player's inventory and then destroy the actor, making it a one-time pickup. Don't forget to enable replication on this actor. Also, add a has authority check to make sure the logic runs only on the server. Drop an instance of the item in your level and run a quick test. As usual, I forgot to configure the interactable properties, but everything still works as expected. The player picks up the key and the item disappears. Now update the interactable component fields to show proper interaction text. Let's go back to the door blueprint. You'll see that the interactable component exposes an interaction conditions array. This makes it very easy to add interaction requirements using modular condition classes, without having to create new interactable component subclasses every time. Here's how to do it. Create a new blueprint and choose interaction prerequisite as the base class. We'll implement a condition that checks whether the player has a specific item in their inventory. There's only one function to override: check interaction condition. From this function we can access the interactor pawn, get their controller and check their inventory. The function returns whether the condition is met or not. If it's not, we can return a custom message, which will automatically be shown to the player in place of the action text. Implement it like this. We'll also add a variable to define which item is required, making the condition fully reusable for any object. Here we check if the required item is in the player inventory or not. Once the class is ready, go back to the door blueprint and add the condition to the interaction conditions array of the interactable component. You'll see the variable is now exposed and we can select the required item directly from there. Let's test the result. At first, the door is locked just like before. We press the button to unlock it. But now the door asks us to have the key in order to open it. We pick up the key. Once we have it, we can open the door. The other player who doesn't have the key still can't interact with it. Everything works perfectly, and you now have a flexible, powerful system for building complex interaction logic in your games. Thanks so much for watching this tutorial all the way through. With Interaction Master, you now have a clean, fully replicated system that's easy to expand and integrate into your gameplay. Whether you're building doors, items, machines, or NPC interactions, everything is handled modularly and fully in blueprints. Interaction Master also works seamlessly with Dialogue and Quest Master, allowing you to build rich dialogues, dynamic quests, and immersive interactions, all working together out of the box. If you need help or have questions, feel free to join the Discord server. Support is available after verifying your purchase. Thanks again, and happy developing.